Now we're going to learn how to solve a right triangle using trig ratios. So here's an example of a right triangle that we can solve using trig ratios. If it's not a special triangle, and there are two types of special triangles, there's a 45-45 and a 30-60. If it's not one of those special triangles, then we have to use trig ratios to solve it. So, which trig ratio uses the things that you know? That's the first thing you want to identify. And then write the trig ratio, and then plug in the given values that you know, and then solve for the unknown. That's how those are the steps. So if you're given one side and one angle of a right triangle, you're going to find the third angle, and then use the given angle and the given side to find the two missing sides. So if you're given two sides, you're going to use the Pythagorean theorem to find the third side, and then use the given sides to solve for the two missing angles. So let's try to solve this right triangle. So notice that we are missing side A, side C, and angle A. So we are given a side and an angle. We're given one side and one angle. So the first thing we want to do is we want to solve for our missing angle. But you're like, wait, there's only one angle. What's this angle? Well, remember, this is a right triangle, which means that this right angle is 90 degrees. And then to find angle A, we just have to do 90 minus 31, because if this is 90, then that means these two have to add up to 90 in order to get 180, which is what triangles add up to, or angles of triangles add up to. So 90 minus 31 gives us 59. Now we want to find side C. So in order to find C, we're going to use our given angle, which is 31, and we have a side that's given, and it's opposite, and we're trying to find the hypotenuse. So opposite and hypotenuse is going to be sine. So we're going to use the sine trig ratio to solve for C. So sine of 31 is supposed to be 5 over C, which means that C is equal to 5 over sine 31. So all I did right here is that I multiplied both sides by C, and I had C sine 31 equals 5, and then I divided both sides by sine of 31, and I got C by itself, and it was equal to 5 divided by sine over 31. Now, if you use your calculator, you need to make sure that you're in degree mode. So right next to the second button, there's a button called mode. And once you hit that button, if you go 3 down, it says radian, and right next to radian, it says degree. You want to make sure that you hit enter where it says degree, and that degree is highlighted, that you are in degree mode for these problems. So once you've done that, you can hit clear to go back to the main screen, and we're going to do 5 divided by sine. Now sine, if you look at the numbers, find the number 7 on your calculator and you go up 2, that's where the sine is. So you'll hit 5 sine 31, close the parentheses, hit enter, and then that is going to give you this really big old long decimal. However, our directions say round to the nearest hundredth, which means we're going to look at the thousandth place, which is an 8 on the calculator. So the 8 rounds up, which changes that 0 to a 1, which gives us the answer of 9.71. Now let's do side A. So, again, we look at the angle that we know, which is 31. We're trying to find the adjacent, and we know the opposite. So, opposite adjacent is going to be tangent. So, tangent of 31 degrees is 5 over A. So, solving for A, I'll multiply both sides by A first. So I have a tan 31 equals 5. Divide both sides by tan 31. And I get a is equal to 5 divided by tan 31. So in the calculator, I'll do 5 divide by. The tan button is 2 above the button 9 on your calculator. So there's tan 31, close the parentheses, hit enter, and I get 8.3213 da 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 da. So we're rounding to the nearest hundredth. So we're going to look at the thousandths, which is a 1, which doesn't do anything for our rounding. So we get 8.32. All right, so let's do another example. We're going to solve this right triangle. So for this right triangle, we're given 2 sides and no angles. However, we know that we know this angle here, angle C, because it is a right angle, which means it is 90 degrees. So first, let's find the angle of measure B. So measure what we are given opposite of B and the hypotenuse, which is going to be sine, the ratio of sine. So sine of B is equal to 15 over 18. So we're trying to solve for angle B, but we have this operation of sine. Now this is not sine times B. Sine is an operation. It's sine B. So to undo a sine, you have to do what's called the arc sine or sine inverse. And if you look on your calculator, right above the 7 where the sine button is, in yellow it says sine and then it has an exponent of -1. So that's the arc sine or the sine inverse. So if you hit your second button and hit second sine, it will pull up your sine inverse, and then you can do 15 divided by 18, close your parentheses, and it will give you 56.44269.024. So that is approximately 56.4 degrees. We can do the same thing to find angle A, except for this time, since we're looking at this perspective, we have the adjacent and the hypotenuse, which means we're going to use cosine. So cosine A is equal to 1518. So to solve for A, to undo the cosine, we're going to do inverse cosine or arc sine. So we'll hit second cosine, which is going to bring up the cosine inverse. So cosine inverse of 15 over 18. And that gives us 33.5573 da 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 da. And so that is approximately 33.6 degrees. Now that we know how to solve right triangles, the question is, well, why in the world would we need to know something like that? Well, we use these in types of problems that mimic triangles. So for example, when you put a ladder against a wall or a building, it creates a right triangle. So in this problem, Sam needs to wash a window that is 15 feet high. His tallest ladder is 18 feet long. So the question is, what angle will his ladder be at? So what angle B, should his ladder be at in order for him to reach the window that is 15 feet high? So you could use, let's see, so you're needing this angle here. So you're looking for an angle, you have opposite and hypotenuse. So you can use the sine ratio to solve for angle B. So other words that will help you solve word problems are angle of elevation. So angle of elevation is the angle formed by a horizontal line and then the line of sight as the observer looks at an object that is above the horizon. So the person is looking up, and it's going to be the angle that is formed by a horizontal line and the line of sight as the observer is looking up. Then you have the angle of depression, and that's going to be formed by the horizontal line and then the line of sight as the observer looks at an object that's below the horizon. So he's looking down. All right, that is all there is to solving problems using trig ratios.